So this is chapter 10, day 6, solving rational equations. And we're going to be going over the basic solving steps. Most of these will look really familiar because they are pieces that we've done before today. So solving step number 1 is to factor all of the denominators. Factor all of the denominators. Step 2 is get the lowest common denominator. And this is what we already have been doing when adding and subtracting. You multiply each fraction by the missing factor or factors over itself until the bottoms match. All right. Step 3, this is the step that's particular to solving. You can only do it when solving because solving is the only time you have an equal sign. So what you're going to do in step 3 is you're going to eliminate all of the denominators by multiplying both sides by the reciprocal. Eliminate all the denominators by multiplying both sides, and by both sides we're talking both sides of the equal sign by the reciprocal of that denominator. That will cause all of the bottoms to cancel out. And you know that we can't solve for x when it's at the bottom of a fraction. So this step should take all of the numbers out and you should have no fractions left. And then it's straightforward solving. So number 4 is your solve step. And there's actually 2 ways we're going to solve. If all you have are x to the power of 1, then you're going to just solve normally, add or subtract x's left, numbers right. And you will get one answer out of that. If it has an x squared in it, then you're going to add or subtract so that you set it equal to 0, and you're going to factor to solve. And this will most likely create 2 to 3 answers, depending on how many factors there are, 1 per factor. Okay, the 5th step, and this is one that's particular to rational fractions, is you need to check for extraneous solutions. And extraneous solutions mean that you did good math, but the answers just happen not to work. And in the case of what we're doing right now, you're looking for anything that creates a 0 in the denominator, because that means that the fraction is undefined for that value. So you do have to either do it in your head, sub it back in, or physically sub it back in. And I'll show you some examples of that. All right, those are the basic 5 steps. So Roman numeral 2, I'm going to introduce you to the solving process by giving you a no solution type of equation. This happens more often in this type of solving than in some of the solving that we've done in the past. All right, let's say that your equation is 5 over x plus 2 equals 5 over x. We are solving, so yes, there is an equal sign. So your first step is to factor all of the denominators. And again, we've been practicing this. So x plus 2 is a binomial. You can't divide anything out. And it's not a squared minus b squared, so that's factored. X is a monomial, which we would normally prime factor. It's already prime. So we're done factoring the denominators. All right, step 2, get the lowest common denominator. So you're going to multiply by the missing factor over itself with the goal that the bottoms match. So the left-hand fraction is missing a monomial x, so we multiply by x over x. The second half, the right half, is missing an x plus 2 factor, so we multiply by x plus 2 over x plus 2. All right, so what we now have is 5x over x times x plus 2 equals 5 times x plus 2 over x times x plus 2. So the bottoms now match. They have the exact same factors. This is where we're going to do step 3. This is where we're going to eliminate the bottoms of the fractions. We're going to eliminate the denominators. So what you're going to do is multiply by the common denominator over 1. So you're going to multiply by x times x plus 2 over 1 on the left. And then because of the equal sign, you do the same on the right. X times x plus 2 over 1. Anytime you multiply a number by its reciprocal, it cancels out. We now have no denominators, and all we have left is 5x equals 5 times x plus 2. So this would be step 4, where we start to solve. At this point, all I see are x's to the power of 1. So this is just going to be normal solving. Add or subtract x's left, numbers right. So you're going to distribute your 5. That gives you 5x plus 10. And again, I promised you this one was weird. So when you subtract your 5x over to the left, the unexpected happens. All of the x's drop out. You have a 0 on the left and a 10 on the right. 0 clearly does not equal 10. So this is a no solution equation. So there is nothing to check for extraneous solutions because we didn't get any solutions. So I don't want you to mix up extraneous solutions versus a no solution equation. No solution meant we didn't get any numbers at all. All right, Roman numeral 3. This time we're going to get answers, and at least one of them will be extraneous. And to remind you, extraneous solutions cause fractions to be undefined because they cause zeros in the bottom of the fractions. So here's our equation. X squared over x minus 1 equals 1 over x minus 1. Now, this one's a particularly nifty problem because guess what? The denominators are already the same. We don't have to make a common denominator. They are already the same. X minus 1 cannot be factored anymore. So we can go straight to the elimination step. So we're going to multiply by the reciprocal of the denominator. So we're going to multiply by x minus 1 over 1. This is legal because we're doing it equally to both sides. If you're doing a problem that has no equal sign, you cannot do this step. It only works with an equal sign. All right, so all of the bottoms cancel out. I have x squared equals 1. You could solve this by extracting square roots, but if you don't think of it, you notice, hey, I have an x to the power of 2, which means I need to factor it equal to 0. So we're going to subtract the 1 over to the left. You get x squared minus 1 equals 0. Then you factor it. This is the difference of two squares. So x plus 1, x minus 1 equals 0. And if you remember from factoring and solving, you take each factor equal to 0 and you solve it individually. You should get one possible solution for every factor. So for the first one, you subtract 1, you get x equals negative 1. For the second one, you add 1, you get x equals 1. Now, this is where you need to figure out if they're both good answers or if one of them is extraneous. You can do this in your head or you can do it in writing. I'm going to have you do it in writing because this is notes, but I strongly suspect you will do a lot of these in your head, and that is perfectly fine. So we're going to check our solutions. You want to go back to your factored form. That's usually the easiest. And let's start with the negative 1. I'm going to substitute it into the original equation. So that gives me negative 1 squared over negative 1 minus 1. We want to know, is that equal to 1 over negative 1 minus 1? So all I did was replace x with a negative 1. Negative 1 times negative 1 is positive 1. And negative 1 minus 1 is negative 2. So yeah, I'm getting the same on both sides, and neither one has a 0 in the denominator. So yes, negative 1 is a good solution. Now we're going to do the same thing with the positive 1. So I have positive 1 squared over 1 minus 1. Is that equal to 1 over 1 minus 1? So 1 times 1 is 1. 1 minus 1 is 0. And right there, you can just stop, because any x value that creates a 0 in the bottom of a fraction is extraneous. You go, but Ms. Right, this one's the same thing. It doesn't matter that they both have a 0. If there's any 0 in the bottom, it's extraneous. So you would list x equals 1 as a possible answer and then write extraneous on it. So again, in your head, if you wanted to take the 1 and just substitute it into the equation, anything that makes the denominator 0 is going to be extraneous. So 1 minus 1 is 0, game over. For the level of problems we're doing, you don't have to worry so much about the left equaling the right. You just need to worry about what creates a 0 in the denominator. Okay, so Roman numeral 4, we're going to do some practice now. We're just going to do 2 more problems to kind of get in the swing of this. So example 1, we're going to do 2 over x plus 1/3 equals 4 over x. Even though it's a very simple looking problem, the steps actually stay the same. So number 1, factor the denominators. Monomials all, so prime factor. X is prime, 3 is prime, x is prime. That's going to happen on some of your problems. All right, now we want to get a common denominator, so multiply by what it's missing over itself. This first fraction needs a 3, so we're going to multiply by 3 over 3. The middle one needs an x, so multiply by x over x. The right one needs a 3, so multiply by 3 over 3. So now we've got 6 over 3x plus x over 3x equals 12 over 3x, and we have a common denominator. All right, now we're going to eliminate. If you have 2 terms on one side, just put them in brackets when you're on the elimination step, and then you multiply by 3x over 1 on both sides. Now, the right cancels out fairly simply. On the left, it's going to cancel both of them out because you're going to distribute that 3x. So when you distribute to the first term, it cancels it out. When you distribute it to the second term, it cancels out also. So this outside blue term here gets used twice, once for each factor. So now we have 6 plus x equals 12. The x is to the power of 1. This is just easy solving. So subtract 6. We get x equals 6. Quick mental check. Will that 6 create a 0 in the denominator? No. That would be a 6. That would be the 6. So we're good. On these, the only thing that would have created a 0 in the denominator would have been if x equaled 0, because 2 over 0 is undefined. But 6 is good to go. All right, last problem. This is not one you're going to see on tonight's homework. You will see it on tomorrow's because it's a little bit longer. It has a trinomial, but I want to at least give you one of the longer problems in your notes so that you have it to refer to. So this is example 2. X over x minus 1 minus 3x over x plus 5 equals negative 24 over a trinomial x squared plus 4x minus 5. Okay, so first thing you need to deal with is the subtraction sign, and we've practiced doing this. So it's very easy. You change it to a plus. You put the top of the fraction in parentheses and you multiply it by a negative 1. The fraction that comes before it is not affected. Neither is the one on the other side of the equal sign. So that negative becomes the negative 1 that gets multiplied by the top. Okay, so now that we've taken care of that, we're going to factor the denominators. X minus 1 is a binomial. You can't divide anything out, and it's not a squared minus b squared because the x isn't squared. We're done. X plus 5 is a binomial. Nothing divides out, and it has a plus, so we're done. This one, though, actually does factor. So the trinomial factors into x plus 5 times x minus 1. So I'm just going to rewrite the other two, except I'm going to multiply the negative 1 times the 3x, make it a negative 3x. And now we are completely factored. So common denominator, multiply by what it's missing over itself. This first fraction is missing an x plus 5. So we multiply by x plus 5 over x plus 5. The middle one is missing an x minus 1. So we multiply by x minus 1 over x minus 1. And the third one already has both. So we're done. They all match. So what have we got? And I'm going to go ahead and we're going to be multiplying the tops out anyway. So I'm going to backwards distribute the x. So x squared plus 5x over the denominator x plus 5, x minus 1. Keep it factored. Plus, I'm going to distribute the negative 3x. So negative 3x squared plus 3x over x plus 5, x minus 1. And the last one, it's negative 24. This one's already simplified, so I'm just going to recopy it. And we now have a common denominator. All right, now the fun part, we get to eliminate all that stuff in the denominator. So put the left-hand side in brackets. We're going to multiply by the reciprocal of the denominator. So x plus 5 times x minus 1 over 1 on both sides. X plus 5, x minus 1 over 1. On the left, when it gets distributed, all the bottoms cancel out. On the right, it just cancels everything out. So now we have the tops. X squared plus 5x minus 3x squared plus 3x equals negative 24. Much simpler to solve. All right, noticing that I have x squareds, we're going to need to make this equal to 0 and then factor it. So first, let's simplify. 1 minus 3 is negative 2x squared. 5x plus 3x is 8x. And if I add 24 to the left, I get a plus 24 equals 0. All right, we're going to factor this, but I can see that I can take a 2 out of all three of those, and I'm going to take a negative out because I don't like my a's to be negative. So we're going to divide negative 2 out of all three of those. So that gives me an x squared minus 4x minus 12 equals 0. Now we're going to factor. So negative 2, and this factors into x minus 6 times x plus 2 equals 0. It's all factored. Now we've got 3 factors, so potentially 3 x's. Set all 3 of them equal to 0. Now, the first one doesn't have an x. 2 is definitely not equal to 0. That does not give us a solution. There was no x to solve for. The middle one, we're going to add 6. So x equals 6. This right one, we're going to subtract 2. So x is negative 2. Now, we're going to do a mental check. But when you mentally check, you want to go back to the factored form because that's the one that's going to show you what will create a 0 in the denominator. So taking a 6, this factor would be 6 minus 1, which is 5. That's fine. That would be 6 plus 5. That's 11. We're good. 6 is a solution. Now let's do the negative 2. Negative 2 plus 5 is 3. That's fine. Negative 2 minus 1 is negative 3. That's fine. None of them create zeros. So we have 2 answers. And you can write your double answers in nifty roster notation. X is an element of the set containing 6 and negative 2. And that is the end of the problem. All right, are there any questions?